it's going to be weird because we finished right here. Okay, so looking at I cubed, you can rewrite that as I squared times I to the first power with the properties of exponents, and then use substitution with the values that you know. I squared is -1. -1 times an I would give me -I. Keep going. I to the fourth can be rewritten as I squared squared. What is I squared? -1. If I simplify that, I get +1. And then yesterday we said there's a pattern. The pattern alternates between 4 answers. And I said to help you remember the pattern when you are evaluating these is to think of quarters. 4 quarters make $1. 4 different answers, 4 different possible remainders, and that will help you get your answer when you are evaluating I to a higher power. We did I to the 37th. You're calibrating it. Instead of evaluating I to the 37th, you're going to calibrate it to its equivalent I to a 1, 2, 3, or 4th power and answer that question. So how do you calibrate it? You take the exponent, divide by 4, and I get 9.25. I need you to understand that this is irrelevant. It's the remainder that we're interested in. It has a remainder of 0.25. How many quarters is that? That's 1 quarter. And so you calibrate it and say I to the 37th is the same answer as I to the first power. Anything to the first power is itself. And that's the answer. And I showed you how your graphing calculator does complex number mode, so you can go in and type that to confirm it. But you need to be able to show the work in between. It's not enough to just type it in the calculator. Okay? Now let's look at B. I to the 58th power. So take the 58, and if you don't want to write like all of that out, you could just come right here and say 58 divided by 4. And what do you get? 14.5, right? So the 0.5 would imply how many quarters? So to calibrate I to the 58 power, and I've run out of room, so I'm going to come right here. I to the 58th power is going to be the same answer as I squared, which is what? -1. So it looks like a super complicated concept, but you're calibrating it down to only 1 of 4 answers. And it's just by the pattern of the remainder. So you try C and D. Yes. So what? How many quarters would that be? 0. So I to the 0. And anything to the 0 power is 1. So I to the 0 is the same as I. Yes. That's where the pattern starts repeating. It's circumstantial in the front row. I don't need to look like I'm covering. This is just where I'll stand. Where's your Y2K? I am Y2K. This is what we wore. We wore Birkenstocks with white socks and boot-cut jeans and tank tops underneath oversized shirts with straightened hair.
That literally looks like something very metal.
which is why fashion repeats itself every 20 years, and all of us are running around like, yes, bring back all of the trend from Y2K. I'm not kidding. This is legit. I almost wore my graduation robe.
A lot of people wore their
Because that would have been my
jacket. Ms. Walker.
If we're really wearing Y2K stuff, it would be pajamas, because everybody stayed at home thinking the world was going to crash on New Year's Eve. Because the news was like, the banks can't handle it, the systems can't handle it, what are we going to do? It was very stupid. So we were literally all at home like,
She was 50 at that time.
You're only 40 during 2000s.
Alright, what'd you get for I to the 75th power?
Negative I.
Oh, wait, let me back up. What did you calibrate it to?
18.75.
And then so I to the... And then what'd you get? Thank you. What about I to the 80th power? What did you calibrate it to?
20.
I to what? Oh, no, I mean I to what power?
Oh,
I to the 0. Okay, and what's that? Unfortunately, there's not a lot of questions to ask about that because it's the same thing every time. So I know you would love like an entire exam on just that, but I know.
I think I get 100.
We'll work on
a
that.
quiz so we can like
That's worth the amount of testing.
Right.
a quiz just so we can like help our grade a little bit.
Yeah, it will be on there.
Oh.
All right, now we've covered add complex numbers, subtract, multiply, raising them to a power. We have not covered division. Here is division. Before we dive into an example, let me remind you of some terminology. You've heard it before with radicals. Now we're talking about it with complex numbers. It is called the conjugate, which is a similar concept to reciprocal, but that's referring to fractions. But you know how reciprocal is the opposite, like you're doing something and manipulating it, so it's the opposite? Okay, conjugate is the same concept, but we're talking about complex numbers. So what is the conjugate? Here's an example. -3 plus 7i. The conjugate would be -3 minus 7i. What do you notice changed? The sign of what?
The imaginary
To
number.
the imaginary number. Okay, here's another one. 14 minus 5i, and the conjugate is 14 plus 5i. The imaginary number is the only thing that has a sign change. Real number stays the same. So keep this in mind. Make note. It is just the imaginary part that gets a sign change. Let's do another example because sometimes this one trips people up. The conjugate of 3i would be what?
Negative 3i.
-3i. That one looks weird because there's no real part. But it's the same concept. You just change the sign of the imaginary part. Now, why do we need the conjugate? Well, when you go to multiply imaginary numbers, complex numbers with their conjugate, what phrase from working with polynomials does this resemble? Do you remember? Change the I to X, and what would it resemble that we've worked with before? All right, let me try it this way. Don't write this. I'm gonna erase it. Don't write it. What's it look like? Yes. And what?
Difference of squares.
There it is. Do you notice how that was a difference of squares from polynomials that you're used to? Now look at it with the complex numbers. It's the same concept, right? So what happens with the difference of squares? What always ended up happening when we multiply them out? Do you remember?
The middle terms will disappear.
There you go. It's going to happen here. Okay? So let's do this. Multiply each of the following. Okay, let's start with this one. We'll go to B first. 8i times -8i would be what? I squared. Okay, and we've been practicing circle the I squared, the number, and the sign, and do what with it? Change it, right? So while that's circled, 64 is the answer.
Because I squared becomes -1 and then you multiply by the -66.
Remember that from yesterday? All right, let's do this one. You can either do the split repeat method here, or you can do first, outer, inner, last. Recall, first, outer, inner, last only works with two binomials, so be careful if you keep using FOIL. If we do the split repeat, we got 5 beep plus 7i beep. Then we're going to repeat 5 minus 7i. 5 minus 7i. And now we're going to multiply it out. What happens in the middle? If they don't cancel, something's wrong. Because like he said, or who, I don't remember who answered, Landon answered, when you're multiplying a difference of squares, the middle term cancels. So keep that in mind, that's a checkpoint. And then we have something to clean up over here. We have I squared number and the sign, and that becomes what? Positive 49 instead. So now I can see I have 25 plus 49, which is what? 74. Now, look at your answers here and here compared to what the problem started with. What do you notice happened? Say it louder. The eyes are gone. Do you see that? That's by design, okay? And the reason why, segue, when you are dividing complex numbers, this says divide 2 minus 5i by 1 minus 6i. Okay, first of all, let's write that in a fraction. We got 2 minus 5i divided by 1 minus 6i. We're going to divide these complex numbers. In order to divide them, you're actually going to multiply by the conjugate of the denominator, and it should eliminate the I in the bottom of the fraction. It's kind of like not allowed to have 0 on bottom, not allowed to have radicals on bottom, not allowed to keep I in the bottom. So this up here, where we came to these plain simple numbers with no I, is going to happen in the bottom, just bottom, of the fraction when you're dividing, okay? All right, so let me show you how to do this. Let's take some notes. We're going to divide 2 minus 5i by 1 minus 6i. To do that, multiply by the conjugate of the denominator. Very similar to when we had radical expressions. Remember this? And you're not allowed to leave a radical in the bottom, so you would multiply by root 3 to get rid of it. Same concept here. We're going to multiply by what is the conjugate of 1 minus 6i? 1 plus 6i. Now, can I just multiply by that? Why do I need to put it in the top as well? Remember, we've talked about how anything over itself is a big old fat fancy 1, which you're allowed to multiply by 1 and nothing changes. So while we're still changing the appearance of that fraction, we're not changing the value of it because we're just multiplying by a 1, a glorified 1. Now, Here's where some people tend to mess up, and it's because they forget that these are binomials. You have a binomial, change colors, binomial, binomial. So you've got binomials on top to multiply, binomials on bottom to multiply, and the ones on the bottom should always be a what? I'm going to call it a difference of squares. Which means you should always just come to a single number, okay? After you multiply successfully, the bottom should come to a single number, no i's involved. It's the top that will still have I. So now we're in familiar territory. So if you understand this, take off with it. If you need a refresher on multiplying, there's a lot to write here. So I'm going to do the distributive property, split repeat. And then start multiplying, combining, and changing any I squares. Check your work along the way. If you didn't get it, let me know. What does negative 30i squared become? And then negative 36i squared. Remember, once you take account into that I squared, you drop it. So I've seen people accidentally write an I after they change the sign, and then don't do that. Once we state that negative 30 times negative 1 becomes positive 30, the I squared has been accounted for and it's gone. Okay? Alright, so here, let me back. So now I have 2 plus 30. Then I have 12i minus 5i. On the bottom, I have 1 plus 36. I have good news and bad news. The good news is that's dividing complex numbers. The bad news is we came to something that has some prime numbers, so this is all we can do. What if that was 36 and that was 6? Everything would be divisible by 2, at least, right? Possibly more. 4, they would be divisible by 4. So you do have to check and make sure all 3 terms don't have a common factor, because if they do, you have to reduce it. One more order of business before the brain break. My math lab does not want you to type it in like this. You should know where this is coming. They want you to type it in as separate fractions. Don't worry. if you look at it, if I can write it as a single fraction and the top is addition, it came from adding two fractions with the same denominator. So this is the equivalent that they would expect you to put in MyMathLab. That's how they want it. So make a note of that. They are the same thing. I personally feel like there's nothing wrong with this, but the algorithm in MyMathLab wants this. Okay. All right, brain break. I'm going to set a timer for 7 minutes. If you need to go to the bathroom,